What are supervised and unsupervised learning? A supervised learning is labeled data to train models where the model learns to map input data to known outputs. Unsupervised learning uses unlabeled data and the model tries to find patterns or groupings without predefined labels. What is that? What is the purpose of feature engineering in machine learning? Phase spaces that can feature engineering involves selecting, modifying, or creating new features to improve model performance and make the data more suitable for training. What is the difference between overfitting and underfitting? Overfitting occurs when a model learns the training data too well, capturing noise and details that don't generalize to new data. Underfitting happens when a model is too simple to capture patterns in the data, resulting in poor performance on both training and test sets. What is cross-validation and why is it important in machine learning? Cross-validation is a technique where the data is split into multiple subsets and the model is trained and validated on different combinations. It helps in assessing model performance more reliably and prevents overfitting. What are training and test datasets and why is it important to split your data? Training data is used to train the model and test data is used to evaluate its performance. Splitting data helps ensure the model generalizes well to unseen data and avoids overfitting to the training set. What is the confusion matrix and how does it help evaluate model performance? A confusion matrix is a table showing the true v's predicted classifications. It helps in evaluating accuracy, precision, recall, and other performance metrics of classification models. What is the difference? Is the difference between classification and regression tasks. Classification involves predicting discrete labels C, G spam or not spam, while regression involves predicting continuous values G, house prices. Phase spaces that can. What is the bias variance trade-off and how does it affect model performance? The variance trade-off refers to the balance between a model to generalize low bias and its sensitivity to data variations low variance set. High bias leads to underfitting and high variance leads to overfitting. What is model evaluation and what metrics would you use for evaluating a classification model? Model evaluation involves assessing the performance of a machine learning model. Common metrics for classification models include accuracy, precision, recall, F1 score, and AUC-ROSEC. Again, phases that can. What is the significance of the loss function in machine learning? That can. The loss function measures how well a model's predictions match the actual values. It guides the optimization process, helping the model improve its accuracy. How do you handle missing data in a dataset? Missing data can be handled by imputation, filling in missing values, removing rows with missing data, or using algorithms that can handle missing data directly. What is data normalization and why is it important? Normalization scales features to a standard range, making it easier for models to learn efficiently. It is especially important for algorithms sensitive to feature scales like neural networks. What is this again? What's the difference between parametric and non-parametric models? Parametric models assume a specific form for the underlying data distribution, G linear regression, while non-parametric models don't make such assumptions and are more flexible. What is feature scaling and when is it necessary in machine learning? Feature scaling involves adjusting features to a common scale. It's necessary when using algorithms like K, means or gradient descent that are sensitive to the scale of input data. Against that, can what is the purpose of regularization in machine learning and what are its types? Regularization prevents overfitting by adding a penalty to the model complexity. Common types are L1 lasso and L2 rigid regularization. Hugging phase space that can. What is the difference between bagging and boosting in ensemble learning? Bagging reduces variance by training multiple models independently and combining their predictions. Boosting improves performance by sequentially training models, where each new model corrects the errors of the previous one. What is the importance of randomization in machine learning? Randomization helps in avoiding overfitting, ensures diverse data subsets, and improves model robustness by preventing the model from memorizing specific data patterns. How do you handle imbalanced datasets in classification problems? Imbalanced datasets can be handled using techniques like oversampling the minority class, undersampling the majority class, or using synthetic data generation methods like SMOTI. What are outliers, and how do they affect machine learning models? Outliers are extreme values that can distort predictions. They can lead to biased models or reduced accuracy, so they may need to be detected and handled. What is the role of validation data in model training? Spaces that can. Validation data is used to tune hyperparameters and assess model performance during training, helping prevent overfitting to the training data. What is a decision boundary in classification problems? A decision boundary separates different classes in the feature space, helping the model decide which class an input belongs to based on its features. What are hyperparameters and how do you tune them in machine learning models? Hyperparameters are settings that control model training, such as learning rate and number of trees in a random forest. They can be tuned using grid search or random search. What are the main differences between generative and discriminative models? Generative models model the distribution of data for each class G naive Bayes, while discriminative models model the decision boundary between classes e.g. logistic regression. What are some common techniques for handling categorical data in machine learning? Categorical data can be handled using methods like one-hot labeling coding or embeddings depending on the model and problem type. Space that can. What is the difference between precision and recall in model evaluation? Precision is the proportion of true positive predictions among all positive predictions, while recall is the proportion of true positive predictions among all actual positives. What is dimensionality reduction and why is it important? Dimensionality reduction reduces the number of input features, helping to prevent overfitting, improve model performance, and reduce computational costs. What is Morging phases model interpretability and why is it important in machine learning? Model interpretability refers to the ability to understand how a model makes decisions. It's important for trust, debugging, and compliance in real-world applications. What is feature selection and why is it necessary in machine learning? Spaces that can. Feature selection involves choosing the most relevant features for model training, improving performance, and reducing overfitting. What is the importance of data preprocessing in machine learning? Data preprocessing improves data quality, handles missing values, and ensures that data is in a suitable format for training, making models more accurate and reliable. What do you understand by model generalization and how can you improve it? Model generalization is the model's ability to perform well on unseen data. It can be improved by using cross-validation, regularization, and avoiding overfitting. Others that can. What is an evaluation metric and why is it important for assessing model performance? An evaluation metric measures how well a model performs. It's crucial for comparing different models and understanding their strengths and weaknesses. What are some ways to improve model accuracy in machine learning? Improving model accuracy can be done by tuning hyperparameters, improving data quality, using more complex models, or adding relevant features. Ken, what is the curse of dimensionality and how can it affect your model's performance? The curse of dimensionality refers to the problems that arise when working with high dimensional data such as overfitting or increased computational cost. Dimensionality reduction can help mitigate this. What is that, Ken? What is the difference between a deterministic model and a probabilistic model? Deterministic models produce the same output for a given input, while probabilistic models incorporate randomness, providing a distribution of possible outcomes. How do you handle multicollinearity in a dataset? Multicollinearity can be addressed by removing one of the correlated features, combining them, or using dimensionality reduction techniques like PCA. What is transfer learning and when would you use it? Transfer learning uses a pre-trained model on a new problem with less data. It's useful when training data is limited but a similar task has sufficient data. What is model drift and how can you detect it in production models? That can model drift occurs when the model's performance degrades over time due to changing data patterns. It can be detected through continuous monitoring and retraining with updated data. What is the significance of data augmentation in machine learning? Data augmentation artificially increases the size of a dataset by creating modified versions of existing data, helping to improve model robustness, especially for image and text data. Spaces that can explain the concept of undersampling and oversampling in dealing with imbalanced datasets. Undersampling reduces the number of instances of the majority class, while oversampling increases the number of instances of the minority class to balance the dataset. How does the size of a dataset impact model performance? A larger dataset typically improves model performance by providing examples to learn from, but too much data can lead to longer training times or computational challenges. What is feature importance and how do you determine it in machine learning models? Feature importance measures the contribution of each feature to the model's predictions. It can be determined using techniques like decision trees, feature importance scores, or permutation tests. Spaces that can. What are some common performance bottlenecks when deploying machine learning models? Bottlenecks can include computational inefficiencies, large model sizes, slow data processing, and difficulties in scaling models to handle large real-time data streams. How do you deal with noisy data in machine learning? Noisy data can be handled by removing outliers, using smoothing techniques, or employing models that are less sensitive to noise, like robust regression. What is the difference between generative and discriminative learning approaches? Generative models model the entire data distribution, while discriminative models focus on distinguishing between classes, which often leads to better classification performance. Space Scan. How do you assess whether a machine learning model is overfitting or underfitting? Overfitting is indicated when a model performs well on training data but poorly on test data, while underfitting shows poor performance on both training and test data. Hugging Face spaces that can. What is model ensembling and why is it effective in machine learning? Model ensembling combines multiple models to improve performance by reducing variance bagging or bias boosting, leading to more robust predictions. What are the trade-offs between precision and recall? Precision and recall are inversely related. Increasing one may decrease the other. Precision focuses on minimizing false positives, while recall focuses on minimizing false negatives. Spaces that can. What are the key factors to consider when choosing a machine learning model? Considerations include the type of problem, classification-based regression, model complexity, interpretability, dataset size, and computational resources. What is the significance of data labeling in supervised learning? Data labeling is essential for supervised learning as it provides the correct answers that the model uses to learn and make predictions. What is the importance of test sets in evaluating machine learning models? Test sets provide an unbiased estimate of model performance on unseen data, helping ensure that the model generalizes well to real-world situations. How do you handle outliers in a dataset and why is it important? Outlier spaces can be handled by removing or transforming them, as they can distort model predictions and reduce accuracy. Spaces that can. What is a recommendation system and what are some approaches to building one? A recommendation system suggests items based on user preferences. Approaches include collaborative filtering, content-based filtering, and hybrid methods. What is the role of feature engineering in improving model performance? Spaces that can. Feature engineering improves model performance by creating new, informative features or transforming existing ones to make the data more suitable for learning. What is this that can? What is the difference between loss and cost functions in machine learning? The loss function calculates the error for a single data point, while the cost function computes the error for the entire dataset, guiding model optimization. How would you handle missing values in a dataset? And missing values can be handled by imputation, filling in missing data, removal of rows or columns, or using models that handle missing values directly. And what are some common challenges you may face when working with real-world data? Challenges include missing or noisy data, imbalanced datasets, lack of labeled data, and computational limitations. Taking spaces that can. What is the difference between a generative model and a discriminative model? They can. Generative models learn the joint probability distribution of is and labels, while discriminative models focus only on the boundary between classes. What is the significance of feature selection in reducing overfitting? Feature selection removes irrelevant or redundant features, reducing model complexity and improving generalization, thus helping to reduce overfitting. How do you balance exploration and exploitation in machine learning models? That can. Balancing exploration and exploitation involves finding a trade-off between trying new actions, exploration, and using known actions that yield the best results, exploitation. Spaces that can, what are the key factors to consider when choosing between different machine learning models? Key factors include the problem type, classification, Weiss regression, data size, model interpretability, training time, and computational resources. Spaces that can, what is the difference between structured and unstructured data in machine learning? Structured data is organized in a tabular format G, spreadsheets, while unstructured data lacks a predefined structure G, text, images. On Huggin, how does one decide on the right evaluation metric for a machine learning model? The choice of evaluation depends on the problem type GG, precision or recall for classification, RMSE for regression, and the specific goals of the project. How would you determine whether your machine learning model is too complex or too simple? By monitoring model performance on both training and test sets, poor test performance may indicate underfitting too simple, while large gaps between training and test performance may indicate overfitting too complex. What are the common pitfalls when working with high dimensional data? Common pitfalls include overfitting, increased computational cost, and the curse of dimensionality. Dimensionality reduction techniques can help. Hugging can, how do you evaluate the stability and robustness of a machine learning model? Stability and robustness are evaluated by testing the model on different datasets, performing cross-validation, and measuring its sensitivity to small changes in input. What are the steps involved in building a machine learning model? Steps include data collection, preprocessing, feature engineering, model selection, training, evaluation, and deployment. Phases that can, what is the difference between a binary classification problem and a multi-class classification problem? Binary classification has two possible output classes, while multi-class classification involves more than two output classes.